Welcome to our video on Cartesian products of sets. In this lesson, we'll learn what Cartesian products are, how to calculate them, and understand their properties through visual examples. Let's start with the definition. The Cartesian product of two sets A and B, written as a cross B, is the set of all ordered pairs where the first element comes from set A and the second element comes from set B. Formally, a cross B equals the set of ordered pairs, A, B, such that A is an element of A and B is an element of B. Let's look at a simple example to understand this better. Let's say we have set A containing the numbers 1 and 2 and set B containing the letters A, B, and C. The Cartesian product, A cross B, consists of all ordered pairs where the first element is from A and the second is from B. So A cross B equals the set containing the pairs 1A, 1B, 1C, 2A, 2B, and 2C. Notice that we have a total of 6 ordered pairs, which makes sense because we have 2 elements in A and 3 elements in B, and 2 times 3 equals 6. Let's visualize this Cartesian product as a grid. We'll put the elements of set A along the vertical axis and the elements of set B along the horizontal axis. Each intersection point represents an ordered pair in the Cartesian product. So these intersections represent all the elements of a cross B that we listed earlier. This grid visualization helps us understand why the Cartesian product of the real number line with itself gives us the Cartesian plane, or r squared. One important property of Cartesian products to remember is that order matters. Let's look at B cross A, which is the Cartesian product in the opposite order. B cross A equals the set containing the pairs A1, A2, B1, B2, C1, and C2. Notice how these ordered pairs are different from a cross B. For example, 1A in a cross B is different from A1 in B cross A. This shows that the Cartesian product is non-commutative, meaning A cross B is generally not equal to B cross A. Now, let's talk about the cardinality of Cartesian products. If set A has m elements and set B has n elements, then the cardinality of a cross B, which is the total number of ordered pairs, equals m times n. In our example, set A has 2 elements, and set B has 3 elements, so the cardinality of a cross B is 2 times 3, which equals 6. This multiplication principle is fundamental in combinatorics and probability, as it helps us count the number of possible combinations. Let's look at another example with different sets. Let set C be the set containing the colors red and green, and let set D be the set containing the shapes circle, triangle, and square. The Cartesian product C cross D consists of all ordered pairs where the first element is a color from C and the second is a shape from D. Visually, we can represent each pair as a colored shape. Cartesian products can also involve infinite sets. For example, the Cartesian product of the set of real numbers with itself, r cross r, is often written as r squared. This gives us the familiar Cartesian coordinate plane, where each point represents an ordered pair of real numbers. For instance, the point 3, 2 corresponds to the ordered pair, where the first coordinate is 3 and the second coordinate is 2. The Cartesian product has several important properties. First, as we've seen, it is generally non-commutative, meaning A cross B is not equal to B cross A. Second, it's associative up to bijection, which means a cross B cross C is equivalent to a cross B cross C. Third, it distributes over union. This means across the union of B and C equals the union of across B and across C. Cartesian products have many applications in real life. For example, in a restaurant, if you can choose one main dish from set M and one side dish from set S, then your possible meal combinations form the Cartesian product M cross S. Each possible meal is an ordered pair consisting of one main dish and one side dish. With 3 main dishes and 4 side dishes, you have a total of 3 times 4, which equals 12 possible meal combinations. Let's summarize what we've learned about Cartesian products. The Cartesian product A cross B is the set of all ordered pairs, AB, where A is from set A and B is from set B. Order matters in Cartesian products, meaning A cross B is generally not equal to B cross A. The cardinality of a cross B equals the cardinality of A times the cardinality of B. Cartesian products can be visualized as grids, with one set forming the rows and the other forming the columns. Cartesian products are fundamental in many areas of mathematics, including coordinate geometry, relations, functions, and combinatorics. Thanks for watching. I hope this helps you understand Cartesian products better.